Hey pre-calc guys, here's your first video. I'm going to break it up into two parts just because sometimes when the videos get long, they take a long time to upload. So I'm going to do just some of the selected problems I told you I was going to do in class. So the first one I said I would do is number 3. It says list the zeros, real and imaginary, of the function. So your real ones are going to be things like a whole number, a fraction. This will also be your like root 5, so your radicals. Your imaginary is your a plus bi. So the first thing we really should do is make our list of the possible rationals, and the way we do that is we do our p over q, right? So before I can do that, let's figure out what my p values are. It's all of my factors of 2, so I have 1 and I have 2. I'm writing plus or minus of both of those. So really the way I should have written that, I'm sorry, would be this. Okay. Then I'm going to do the same thing for q. So q is my leading coefficient. I want all the factors of that, and that also is just going to be 1 and 2. So if I were to make a list for p over q, I'm going to get plus or minus. I'm going to do 1 divided by 1 is 1. 1 divided by 2 is 1/2. Right? 2 divided by 1 is 2, and 2 divided by 2 is 1. So there's my full list. So I have plus or minus 1, plus or minus 1/2, and plus or minus 2. The next best thing you're going to do, especially if you don't have a calculator, is you're going to use synthetic division to determine which of these could possibly be zeros. You're going to have a 0 when your remainder is 0. So I already know what the answers are, so I'm just going to take you through the process of synthetic division. I mean, I guess I could show you guys. I'm just going to jump to one of the ones that I know works. So I'm going to start with -2. I'm going to take all of my coefficients, so 2, 5. Remember, if there was no x squared term, I'd have to put in a 0 here, so don't forget about that. So I drop my 2, I multiply by -2 and I get -4. I add and I get 1. I multiply by -2. I add, I get 2. I multiply by -2. I add, I multiply by -2. And you'll notice my remainder is 0. So that lets me know that I did, in fact, have a factor. If you were to test something like maybe a +1, this remainder wouldn't have been 0. So that's how you would have known that wouldn't have been one of your factors. Well, I already know, because I've already done the problem, that -1/2 will be another one of my factors. So I'm going to do -1/2, but I'm going to start with my my new coefficients, because I know after I've divided by my x plus 2, or the one that has a factor of -2 as my 0, I'm sorry, I'm now going to have 2x cubed plus x squared plus 2x plus 1. So I'm going to use that shortened version so I can squeeze this in. So I'm going to drop the 2. I multiply by a -1/2 and I get a -1. I add and I get 0. I multiply, I get 0. I add, I get 2. I multiply by a -1/2. I get a -1. I get my remainder of 0. So at this point, I know that I have x plus 2. I got that factor here. So this came from the fact that -2 is a 0. That's what makes this factor 0. I have x plus 1/2. And I also know I have a 2x squared plus 2 left over. Sorry, I was just thinking for a minute. Okay, so when I see that, I know I need to solve this. To make things a little easier for myself, I'm going to factor out a 2, so I'm going to put that in front. So that leaves me just with an x squared plus 1. Well, that's a little easier to solve. So I'm going to have x squared plus 1 is equal to 0. That means I get an x squared is equal to a -1. So when I take the square root, I get x equals plus or minus the square root of -1. Well, we know -1, the square root of -1 is just I, so I get plus or minus I. So if I want my full list of values, or my full list of zeros, we had -2, we had -1/2, and we have plus or minus I. Okay, so there's number 3. Let's move on to number 8. It says find all of the zeros of the function given that -5i is a 0. So the nice thing about this is we've already given you a 0. Because this is an imaginary root, it's going to have a partner, and it's going to be its conjugate. And the way we find the conjugate, maybe I'll write it like this. If we have a plus bi, my conjugate will be a minus bi. So whenever, we always have one for each of these forms. So a plus bi and a minus bi. So that means if I have -5i, I'm also going to have one that's plus 5i. So I know I have x this is my factor, so plus 5i, which means I'm also going to have an x minus 5i. I'm going to have another term. Notice this is x cubed. That means I'm going to have 3 roots. That one's going to have to be real because there won't be enough for it to have a partner. So let's FOIL. So x times x is x squared. X times this is going to be a minus 5ix. This times this will be a plus 5ix. If I multiply these together, I'm going to get a minus 25i squared. So if we simplify this, I'll be left with an x squared plus 25. Remember, I squared is saying take the square root of -1 and square it. That's going to give me a value of -1. I squared is multiplied by this. I'll get a positive 25. But I need to figure out what the remaining zeros are. So the easiest way to do this is say, okay, I know that we can take this out of my function. We're going to divide it away to figure out what's left, what our remaining factor is. So I'm going to use long division. I think that's the easiest way to do this. I have an x cubed. Oops, I might write out of space. Remember in class we talked about sometimes we need ghost terms, but in this case we're good. We have an x cubed, x squared, an x, and then a constant term. So x squared is going to go into x cubed x times. So that's going to give me x cubed. Oh, okay, so notice here I don't have an x term. So when I multiply x by this, I'm actually going to line this up over here. So I'm going to have a plus 25x. Okay, so when I subtract, those will cancel out. When I subtract, those will cancel out. So I'm going to bring this down. Now I'm going to have a 3x squared plus 75 is really what I have. Okay, well, x squared is going to go into 3x squared 3 times. So 3 times x squared will be 3x squared. 3 times 25 will be 75. Well, that was convenient because when I subtract this away, those will go away. So I have a remainder of 0. So notice my last 0 is going to be -3. So if I want to make a list of my zeros, I will say my zeros were plus or minus 5i, and then we just found our newest one, which was -3. Okay, so far so good. Let's keep going. Number 9 says use your calculator to find the zeros. So I'm going to take out my calculator really fast. So I already graphed something. I need to clear really fast. Okay, so I'm going to go to my y equals. And I'm going to type this in. So I have 2x cubed minus, whoopsies, 10.57x squared minus 4.11x plus 26.1. Let's hope that's all typed in there correctly. Looks good to me. So now I'm going to graph. Now notice it says x cubed. So at most I'm going to have 3 roots or 3 places it crosses. And then you'll notice if we look, we have those. If we want to figure out where the zeros are, I'm going to do second calc, and then we want to find our 0 values. So I'm going to push enter. It's going to want us to find a left bound. So I'm going to do this one over here first. Notice my x set should cross. There it is. So my left bound has to be just to this side of it. I'm going to push enter. My right bound, I'm going to scroll up a little bit. And then when I do my guess, I can't really get more precise. So I'll just push enter again. But you'll notice I'll calculate where my y is 0. And my first 0 is at -1.541. Remember, we always want to round to the thousandths place. So my first 0 is -1.541. Okay, let's find our next one. I'm going to do a second calc 0. So we're going to scroll over. So you guys can see, sorry. So I want my little cursor. It's coming, it's coming. There it is. Okay, so there's my left bound. There's my right bound. There's my guess. And there's my next 0. So at 1.629, we've got to do this one more time. Second calc intersect, oopsie, sorry, second calc 0. We're going to scroll over. There it comes back. There's my left bound. There's my right bound. And then there's my guess. Okay, so notice on this one I got -1.7e to the -11. That means -1.7 times 10 to the -11. That means we're going to shift our decimal points from this over 11 times. This is practically 0. Sometimes the calculator doesn't, for lack of a better way, it has issues with 0 sometimes. Let's just put it that way. But this is approximately 0, so I'm okay with that answer. So I'm going to get 5.197. If you guys want to talk about this in class, we can. But yeah, whenever you get something like e to the negative, something bigger even than 3 or 4, typically that's a close-up approximation to 0 for us. Okay, let's keep going. So these are my 3 answers. I know there's only going to be 3 because I know it's a degree 3 function, so I can't have more than 3 roots or 3 zeros. Okay, down to domain of functions. Let's take a look. So we've been talking about where we might have problems. So some places that we might have problems would be at maybe at a whole. So when we have a factor in the numerator and the denominator, vertical asymptotes, that's a problem for the domain. Oh, this is just domain, so we don't have to worry about horizontal asymptotes. So wholes, vertical asymptotes, there's one I'm missing. Oh, when we have a negative under the radical sign. So let's just do these two together really fast. So for number 12, let's factor this to make sure we don't end up having a whole. So I'm going to end up with an x, it looks like minus 4, and then an x minus 3. And down here I have an x plus 5, so I don't see any problems there. But I am going to have a vertical asymptote. It's when my denominator is 0, so x cannot equal 5. So that's my first thing about. I'm trying to think of anything else. We're not going to have any radicals. So I think that's our only real problem. So now we have to write our domain. So my domain is from negative infinity all the way up to 5. Oops, sorry, this should have been a negative 5. I can't include negative 5, but I can start back again after negative 5 and go all the way into infinity. So there's my domain for number 12. Okay, for number 15, I don't think we're going to have any wholes because I would need the denominator to be 0 when the numerator is also 0. If I plug in 0 minus 0 plus 1, no, we're definitely good. Now we want to look for any, vertical asymptotes. So let's see if we're going to have any. We're going to figure out where the denominator is 0. So let's see what we get. Okay. If I were to factor this, I believe we get an x minus 1 squared. Okay, well, let's think about what this really means. If I were to graph this, it means at a positive 1, it's going to hit and turn back around. Well, that's really interesting because that means that this denominator is never going to be negative, or at least what's under the radical, so I don't have to worry about this, but it is going to hit at 0, and we're going to have a vertical asymptote there. And my problem is specifically at x equals 1, so x cannot equal 1. So if I'm trying to write my domain, I'm going to say I can go from negative infinity all the way to 1. I can start back up again at 1 and keep going. So there's my domain for number 15. So I'm going to stop this video, and I'll do a second video for some of the problems on the back.